So my Milwaukee M18 9.0 gave up the ghost, started just flashing all over the place. One of the cells were really bad and the other ones just kind of got jacked up and toasted. So online on Amazon you can find replacement like kits that you can build your own, similar battery. And so I ordered one from Amazon. And when you go and find the manual inside these, I've done one before, they don't explain too well how the 15 cell 9 amp battery works. So I just wanted to do a quick video just to kind of show. So right here it's got the user manual for 15 cells. And then right here it kind of explains how the battery system works, and then if you check the QR code it'll bring you to another one where I think it's like a, well, they have one for the 5 amp hour one, so it's got less cells, so you don't really know exactly how to do it. So this is just a quick video on just showing you how to do it with the 15 cells. So this is what you get. You open that up, it's got the little logic board in there. Then inside that piece, this is the brains, 2 little squeeze portions for it to go in to a Milwaukee charger, and then it's got springs and all the assembly that goes with it. So here's where you house the batteries. This opens up. Nickel plates. So this is the little tab to see the battery indicator. This isolates a little bit. This is the negative that connects to when the batteries are all wired up. Positive. 2 springs that go over here. Then a bunch of screws. And if you separate the screws aside, you'll see that they're a few different sizes. So, and on the Milwaukee batteries themselves, they use the security Torx, but these ones are just regular. So you have one kind of wood screw pointy one. You got 1, 2, 3, 5 of these, 4 of these guys, 5 of these longer ones. Sorry, 7 of these longer ones. So this is how they're kind of spread out. These 2 springs. Each spring goes in here, and the rest in there, and you can pinch them. So this is the this is the temperature, so it'll kill the battery or the voltage if it gets too hot. That's the little indicator for the power level. So it's got 1, 2, 3, 4 LEDs, just like the original. And then right here you have 2 connections. Right here you have 2 connections. And here is the negative, and here is the positive for the wire that comes supplied. So here, at some point, you'll put the positive here. And the negative in here. And the wires are, they're a little tinned. So this one's tinned a bit, and this one isn't. The gauge of the wire isn't that thick, so part of me actually wants to bring my own wires in. And then you'll have 4 of these tabs, and each one, this isn't the right exact place, but each one will actually go in here, and then those get soldered in. So You'll need a soldering iron. That'll solder this point, this point, this point, and this point is where you're going to be soldering, and then right here and right here, this is negative, this is positive, will be going underneath and into the main. So the main 18 volt, you know, or it'll be a little over 20 volts, but 18 volts will be here and there, and then these ones will just actually just connect to just check the voltage. So I think it's like 4 volts on negative, positive on those. So it also comes with Milwaukee-esque stickers that'll go in the back. So these, one here, and one here. Very similar to kind of how Milwaukee does it, or similar enough, but not so similar that you get a copyright issue or trademark. So that's what we need. So the main thing that you want to do is you're going to be, so this is made for spot welding, and you can get these really cheap, or you know, pretty cool little spot welders that are lithium ion that you can just, you know, spot weld these onto the battery. And the key for these batteries is to actually not put too much heat, or do a concentrated amount of heat enough to do the quick weld without heating up the entire batteries. My brother warrantied his electric bike, and so I gutted all the batteries out of them, and they're really nice. They all tested really well. The problem that it got warrantied was because it wasn't charging, and so it turned out just to be the terminal for the charger, but they just warrantied the entire thing. But these are really nice, you know, LG cells, and so I went in and charged every one of these so they're all balanced out. So one thing that people talk about a lot is to balance these out and have batteries. So not so much make sure the batteries are good, but make sure that the voltage is similar and also the same brand or chemistry for each battery that so for each setup. So don't mix the batteries is kind of the most important thing, and also have them be all topped up and with you know, similar kind of use and wear. So I'll need 15 of these guys. And then I always stack them kind of always positive up, or just make them all the same direction. You kind of just don't want them crisscrossing. So that's what you'll need there. And then you'll also need a little bit of flux. It's a little overkill, but you know, soldering iron. A bit set. This is a cool little Wera driver set that I just picked up. It's pretty cool. So this is a little spot welder I got on Amazon. It's pretty handy. I've only used it on the max setting, to be honest, because the other ones it just didn't heat it up as much. So you turn it on, hold the button, and right there it's at 11. So it'll go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it's at max power. It's at auto, meaning that as soon as it makes contact, it'll automatically give it a burst and then turn off. You can also do manual, and in the manual mode you'll click the button here and tell it to you know, weld for the period of time that your finger's held down there. Turn that off for now. So right here is the casing for it, and you'll notice that right here, you'll notice that on one side it's flat, so this is the bottom, this is the top, and on the top the electrical or the connections will be here, and the button to turn it on will be over here. So it'll be like this, and you'll be able to tell because it's got these dimples right here at the top, and they'll kind of just dock in like that, and it locks in here, right? And so if you can imagine, the case goes just like that. So you can click the button there. So knowing that that's the orientation, right here will be the stack of positive, then it'll go negative, and then positive, then negative, then finish off with positive. Obviously the opposite on the other side. So, knowing that, scoot that over, start stacking your cells. So, oh yeah, and then something else. When I pulled these out, obviously you kind of have to pry them up because they're spot welded. So I just ran just a quick finger sander with like, I don't know, like 180 grit. It just knocked off the top and the bottom just to, you know, smooth it out. Obviously watch out because, you know, batteries are dangerous, etc. This is the positive, negative, and the whole shell casing is negative. So if that touches metal here, it will short out. Oh, and another thing, if you're going to be doing this, do not do it on a metal surface. You know, sometimes people have, you know, stainless tables or whatever, work tables. Or make sure that, be aware that these will, you know, short and can cause, you know, sparking, or, you know, it'll heat up. You know how batteries work. So just keep an eye out for that. So they're all oriented that way. So positive, negative, positive, negative, positive. Over here, give it a nice smush. Make sure, depending on the build quality, but just make sure that it's resting nice and flush with it. You know, like you should be able to see the 2 points where the screws meet, or where you're going to be screwing in. Those should be touching right there, right there. You know, everything should be nice and flat. So there is spacing here, but the screw points are nicely, you know, placed or meeting. So at this point, the screws that you're going to use are these ones over here. There's a total of 5. 1, 2, 3, 4, and 5. And they are T10s. Okay. So at this point, you're going to be wanting to put these plates on, and they're all, you can't really mess them up because they only fit in one way. These little holes right here match up with the little locator tabs. Now what I've noticed is that with these locator tabs and the bends, you know, like this came out of the factory a little bit bent, so it's not that big of a deal. You kind of want it kind of, if you're going to have the bend, have it bend inward, so to not have it, you want this to be bent in and not out. And another thing that I've noticed is that, you know, if this is supposed to be like a one-time thing, right? So when you put these on and they're, you know, housed in there, I think this is actually this one. So in the when you're putting this together and when it's matched up, so this one's already matched in here. This one fits into a little kind of docks in there. So that one's locked in there. So everybody's locked in here. So at this point, you know, it's enough for it to be, you know, good. But if you want just kind of the peace of mind that, you know, the plate is going to just stay. I mean, part of what I did was just actually use the soldering iron and just like melt the plastic, you know, to kind of, I guess for lack of a better word, to peen those little points and just kind of smush it in there, and then just make sure that everything's in its location. Because as soon as it kind of gets dangerous is, you know, right here, a positive to negative is where danger is. But as soon as you start, you know, daisy chaining everything together, then all of a sudden these guys become dangerous, because as soon as these two, you know, they'll short out if these two touch, you know, etc. So right now, every battery is independent of the other, and so you could lay things out and touch them. So long as you're not touching both of these sides, you're fine. But as soon as this plate's put on and that plate's put on, then it's, you know, the circuit completes right here, and that's where it becomes, you know, a little hairy. So I like to just melt these little points to kind of just make sure that everything's, you know, placed back. You can see how this one's lifted up a little bit. See that? So doing this, now it's kind of firmer in there. This is where it gets a little hairy. You don't want anything to be touching, so it's kind of like a game of operation. So they're all kind of just smushed in there. But now they're not going to be coming off. That's kind of when you want to be kind of sure of, is that they're not going to be bouncing around. So now that that's done, we're going to do the spot welding. After that, what I like to do is actually just grab anything that's non-conductive and just kind of see how that one's a little loose. Both of those are. That one's good. That one's loose. That one's good. So that one's bad. That one's bad. Sometimes you can't go into the locations where, you know, the little dimples, and you just have to go to the side. Good. Good, good. That one's not good. That one's not good. Wow. All right. The power's still full. These things are incredible. It's a little warm, but not bad. But so right here, each one of these holes, so 4 of them, 1, 2, 3, and 4, and then, like I said before, your positive goes in here, soldered, and then it lands right here in a puddle of solder, and then your negative does the same thing, connects right here, solder, and then you can route it back here and in here, and it'll go into a puddle of solder right here. If I were you, I would change this wire. The gauge is just too thin. And besides that, once you do that, and then also you're going to want to tin. I think it's a good idea just to put a little bit of flux, tin right here. I wouldn't tin right here because of the holes. You want it to drop in there. You want to create a little puddle of tin here, a little puddle of tin here, and then tin your wires. Let's do that. This is the Amazon one. This is the one I'm going to end up using. It's a little bit beefier. A little bit of flux. Grab my Q-tip, put a little bit of flux just on these points. Now at this point, when I drop it in here, if the negative and the positive touch, the LEDs will light up. Even if the positive touches, the LED will light up, probably with a warning saying like we don't have a ground, but we do have a positive. So I just like to tilt it up a little bit right here so they won't touch. So you can, solder up the 4 little blades that pop up. Okay, so now that we're good, let's go ahead and drop a little bit of solder here, those 4 places. Okay. Now we want some tweezers or something to give it, to be able to, press down. So as soon as this touches, this guy is going to light up. Run a little diagnostic and probably going to say, warning. Just want to make sure there's clearance for the wire. Looks okay. So anyway, let's drop the positive in there. We lost a pen. Just the cap, and then this. As soon as you touch here, everything's going to be wired up. Okay. So now everything is where it's supposed to be. Your positive here, your negative here. These points are soldered, and then this is your positive. This is your negative. That's your positive. Battery is full. Go ahead and drop that in here. Then you're going to have your screws. Now we're going to switch off from the T10 to a Phillips head. The longer wood screw one, I'm pretty sure, actually this is actually not. So this is a T. So this little pointy wood screw one is actually, I think it's a T8. Yeah. That drops in right here. Keep it a little loose, because the one that goes right there, for some reason, isn't too excited about. Isn't located too well. Okay, so now we're good there. This little isolator actually insulator goes up and over here, I think. Anyway, you can put the pad there if you want. I'm not going to. So now let's build out the mechanism to open and close. You gotta press one all the way in, grab something small, reach in there, compress the other spring. That's that. 4 screws. Just watch out for the wires. Make sure that they're clear as you go in there. You don't want it to pinch. 4 screws here to hold the battery to the bottom. Okay. 2 screws that are left, or the 4 screws that are left. Back to the T10. Obviously the smaller ones go on the grab our stickers. There we have it. I'm just going to write the date. It's been July 2024, LG cells, just to know. Let's test it out. Oof. Still full. Geez, it's still full. So on my 5 amp hour battery, that would have definitely been half full. The 9 amp hour battery, the original 9 amp that I had, would have definitely been, you know, at least 1 bar. Let's see if I can charge it. These Chinese batteries often have like a issue like docking. This is an original one. Slides in just fine. Oh, I gotta tighten this back. I gotta tighten the screws a little bit more. I'm looking here. It looks like the second to left pin is a little crunched or something. See if I can spread that out for a little bit. So these little the pads to charge seem to have been a little bit too tight. So just a heads up, when you do it, maybe just make sure they slide in nicely. Like before you connect the battery to it, just run like a flathead screwdriver or something. Just make sure you know it goes in nicely. See if that does it. There it goes. So it already, there was so little battery taken up that used that it's already flashing like it's green. But main point is that it's charging, and now it slides in nicely. Cool. So just keep that in mind when you do yours, to make sure that those guys right there, you can put something in freely, and obviously it's safer to do it when the battery is not when it's not all put together. So anyway, what I have to say about it seems to be working just great. The only tips that I would have were to use a thicker gauge positive wire, and then also make sure that the blades are nice and clear for you to be able to slot it in comfortably in the charger. It just seemed it was just a bit too tight. But setting that aside, this is basically only as good as the quality of cells that you have, right? So if these are really nice LG, almost brand new cells, so you can use those, or just grab whatever you have. Just make sure they're kind of matched up in charge and kind of in use. And then you can grab this for 20 something bucks on Amazon and put together a battery that, you know, is as good a quality. Sometimes, I mean, obviously the mother or the board isn't as good as the Milwaukee one, but the cells are as good, if not better. LG cells are incredible compared to this. And you know, you can also use the casing for this Milwaukee one inside this guy and probably do just as good of a job. It should probably bolt up just fine. So hope that helps.